Assume we have a game. The point of this game is to control a car to get it to reach the finish line. The faster it reaches the finish line, the better score it receives. The car is only allowed to drive on the road, and if it deviates from the road, it dies. Essentially, this is a game every human could learn in seconds. So going from this simple game, how would we go about making an AI that would be able to complete all given racetracks in an acceptable amount of time? Let's look at a car. There are three basic actions we can take to control the car. The car can accelerate, steer left, or steer right. These basic actions have to be combined in different ways in order to maneuver through the track. For example, the car can't steer in place, it has to be moving to be able to steer. Another special implementation on the car is that it can't brake. The only way the car can slow down is from air resistance on the car or friction from the wheels. While this is easy for a human to understand, the AI has to learn these things itself. The brain of the car is a multilayered perceptron. In our case, it'll have three layers: the input layer, hidden layer, and output layer. The input layer will consist of neurons containing relevant information about the car. There will be the car's current angle, the car's relevant velocities like the x velocity and the y velocity, and its angular velocity. The brain would also need to know its position relative to the racetrack. Here, we could use 4 sensors that would detect the distance to the end of the road in each of the respective directions. The brain receiving these inputs would then output which of the 3 choices it should take. We can train the car's brain using Neuroevolution. Let's say we start with 100 cars. All these cars' brains are randomly initialized. At the start, all the cars will do badly, since they are just more or less taking random actions. But some cars are going to do worse than others. We sort them by how well they did, and then kill the bottom 80%. Then we clone each car in our remaining population with small changes to their brain called mutations. We clone enough so that we're back at our initial 100 population. These series of events remind of evolution, where only the strong survive and can pass off their genes to the next generation. A series of these generations and we have a car that can navigate through our entire track. So let's run the program and see the cars learn. As you can see, the cars slowly get better and better every generation, until they beat the track. In this run, they've managed to complete the racetrack in 60 generations. After having trained a neural network, it's usually good practice to test it against unseen data. This is done to make sure that it isn't overfitting the data. It's important to remember that the cars don't only learn to drive the specific track they were trained in. They actually learn through machine learning to navigate through most tracks that have the same format. Anyways, that's it for this video. Please do leave a like and subscribe if you enjoyed it. Thanks for watching.